Welcome to Chapter 4. We've learned how to put data into Kafka. Now let's learn how to get it out. Consuming messages has a lot of nuance, especially around consumer groups, rebalancing, and offset management. Consumer groups are Kafka's killer feature for scalable consumption. This issue, it works. Multiple consumers share the same group.id. Kafka automatically distributes partitions among them. Each partition goes to exactly one consumer in the group. You scale by adding more consumers. Key rules. If you have more consumers than partitions, the extras sit idle. Multiple consumer groups can read the same topic independently. They maintain separate offsets. When consumers join or leave, Kafka triggers a rebalance to redistribute partitions. This is what makes Kafka different from traditional queues. Data is written once but consumed many times by different groups. Rebalancing is how Kafka redistributes partitions when the group membership changes. There are two approaches. Eager rebalance, the old way. All consumers stop, ALL partitions are revoked, everyone rejoins and gets new assignments. It's a brief but total disruption, like stopping all highway traffic to repaint lane markers. Cooperative incremental rebalance, the modern way. Only the partitions that need to move are reassigned. Other consumers keep processing without interruption. Minimal disruption. Always prefer cooperative rebalancing in production. Use cooperative sticky assigner as your partition assignment strategy. The heart of the consumer is the poll loop. It does way more than just fetch messages. Every call to poll fetches records and sends heartbeats to the group coordinator and handles rebalances. You must call it regularly. If you don't call within max.poll.interval.ms default 5 minutes, the coordinator assumes you're dead and triggers a rebalance. Each poll returns records with topic, partition, offset, key, value, and timestamp. If your processing takes a long time, either reduce max.poll.records so each poll returns fewer messages, or increase the poll interval. Don't let processing time exceed the interval. Offset management is where reliability gets real. You have 3 main strategies. Auto-commit, enable.auto.commit equals true commits every 5 seconds. Simple but risky. If you crash between commits, you either lose messages or get duplicates depending on timing. Commit sync. Blocks until the commit succeeds, retries on failure. Use this on shutdown and during rebalances. You're guaranteed the commit went through. Commit async. Non-blocking, fires and forgets. Use this during normal processing for better throughput. If it fails, you don't retry, because a newer offset might already be committed. The best practice: use commit async during normal processing for speed, and commit sync in your shutdown hook and rebalance listener for safety. The configuration settings that matter most. Auto.offset.reset. What to do when there's no committed offset. Earliest starts from the beginning, latest skips to new messages only, none, throws an error. Max.poll.records. Maximum records returned per poll call, default 500. Reduce this if processing is slow. Session.timeout.ms, heartbeat timeout, default 10 seconds. If the coordinator doesn't hear from you in this window, you're considered dead. Partition.assignment.strategy, range, round robin, sticky, or cooperative sticky. Use cooperative sticky for production. Enable.auto.commit. Disable this for explicit offset control. Manual commits give you precise delivery guarantees. The key takeaway is that consumer groups scale consumption. Cooperative rebalancing minimizes disruption. Manual offset commits give you control over delivery guarantees. And the golden rule: commit after processing, never before. Committing before processing and then crashing means the message is skipped forever. Now let's review with a question. What happens if you add more consumers than partitions to a group? Take a moment to think about it. The answer is, extra consumers remain idle. Each partition can only be assigned to one consumer within a group. They're standby, ready to take over if someone fails. Review question 2. Why should you commit offsets after processing, not before? Consider what could happen in case of a crash. The answer is that if you commit before processing and crash, the message is skipped. It's lost. Committing after ensures at least once delivery. In the worst case, you reprocess, but you never lose data. Thank you for watching and see you in our next video.